Welcome. Have you ever really stopped to think about how the lines of code a developer types up on their screen somehow become a fully working app on your phone? Well, today, we're going to pull back the curtain on the unsung heroes of that entire process, the build tools. They are quite literally the engines that make modern software happen.
All right, so here's our game plan. We're going to start with the core problem, like why do these tools even need to exist? Then we'll trace their history, from the early days to today's super fast options. After that, we'll put them head to head. And finally, we'll zoom out to see how they fit into the whole DevOps universe.
So, first things first, let's really get a handle on the basic challenge here. Every single software project, whether it's tiny or absolutely massive, has to figure out how to turn mountains of source code files into one single working product. And believe me, that process is, well, it's chaotic. Yeah, it's definitely not as simple as clicking a button. All that code needs to be compiled, all the right libraries have to be found and pulled in, a ton of tests have to be run, and then everything needs to be packaged up just right. Trying to do all of that by hand? It's a complete recipe for disaster. Think about it this way. A manual build is like trying to bake a really complicated cake without a recipe. It's just chaos. You're probably going to forget an ingredient, and it's going to taste different every single time you try. But an automated build tool, that's your recipe. It's a precise, step-by-step set of instructions that guarantees a perfect result every single time. It brings order and reliability to the whole mess. So how did we even get to the powerful tools we have today? Well, it's really a story of evolution, where each new tool was basically created to fix the frustrations of the last one. And it all started with this guy, Apache Ant. You can think of Ant as the old-school master craftsman. It gave developers total, absolute control. You had to write these XML files telling it exactly what to do, compile this specific file, copy it over to that folder, zip these things together. It was incredibly powerful and super flexible. But here's the catch. That total flexibility was also its greatest weakness. Every single project had its own unique and often gigantic build script. And worse, there was no standard way to handle outside code libraries, which led to a nightmare developers called jar hell, just this horrible mess of conflicting library versions that could bring your entire application crashing down. It was pretty clear. The community knew there had to be a more standardized, less painful approach to building software. And that better way was Apache Maven. So if Ant was the free-form craftsman, Maven was the opinionated foreman on the job site. Maven came along with a truly radical idea: convention over configuration. Basically, instead of writing out every single step, you just organize your project the Maven way, and it automatically knows what to do. Oh, and it introduced automated dependency management, which, wow, was an absolute game changer. Jar hell was finally over. Now, this right here, this is the genius of Maven. Every single project that uses Maven follows this exact same standard lifecycle. That means any developer can jump onto any Maven project anywhere in the world and instantly know how it's built. It created a universal recipe, and that brought some much-needed sanity and consistency to the software world. So Maven was great. It standardized everything. But you know how it goes. Developers started to miss some of the raw flexibility they had with Ant, and pretty soon, everyone wanted more speed. The stage was set for the next big thing. And that's when Gradle showed up, the high-performance engineer. Gradle basically took the best ideas from both Ant and Maven. It kept the structure and dependency management from Maven, but it threw out the rigid XML files. Instead, it uses a flexible and way more powerful scripting language like Groovy or Kotlin. This was a huge leap. It meant you could write actual code to control your build, giving you the structure of Maven but with the power of Ant, and it was all built for one thing: speed. And when I say speed, I'm not talking about a small improvement. Thanks to some really clever tricks like incremental builds, where it only rebuilds the parts of the code that have actually changed, and a build cache, Gradle can be insanely fast. In some cases, up to 100 times faster than Maven. For a big project, that's a massive amount of saved time. Okay, so we've got the flexible craftsman, the standardizing foreman, and the high-performance engineer. Let's put them all side by side and see how they really stack up. Because choosing a build tool is all about trade-offs, right? You're balancing flexibility against standardization, against pure performance. And the right answer? Well, it really depends on what your project actually needs. And this table just lays it all out perfectly. Ant gives you that ultimate fine-grained control, but you have to do all the work yourself. Maven is fantastic for standardization, but it can feel really rigid if you need to do something unusual. And then there's Gradle, which strikes this amazing balance, giving you incredible performance and flexibility. The catch, that flexibility comes with a steeper learning curve, since you're basically programming your build. This is a big reason why it's become the go-to tool for really complex, modern projects, especially in the entire Android ecosystem.
All right, so let's zoom out. How do these tools fit into the bigger picture of software development? Because they don't just exist in a bubble, no. They are the absolute engine at the heart of the modern DevOps world.
So once our build tool has followed its recipe and done its job, the final thing it produces is called an artifact. And that's really the key output here. It's the finished product, the neatly packaged, ready-to-run version of your entire application.
Now, in the Java world, you'll hear about two common types of artifacts all the time. First, you've got a jar, or a Java archive. This has all the core code and libraries. Think of it as the application's engine. Then you have a WAR, or Web Application Archive. This one is specifically for websites. It bundles up all the web pages, images, and server code into one package that's ready to be deployed. Okay, so an artifact gets created, then what? Well, it gets stored in something called an artifact repository. Just think of this as a super secure, version-controlled warehouse for all of your finished software components. It makes them really easy to find, manage, and deploy later on. And this slide, this is where it all comes together in what we call a CI/CD pipeline. Here's how it works. A developer writes some new code and commits it. That simple action automatically kicks off a build server. That server then uses our build tool, Maven or Gradle, to run the whole recipe, compile, test, and package everything up into that final artifact. Then, that brand new artifact gets pushed into the repository warehouse for safekeeping. And from there, the pipeline can automatically deploy it to live servers. See? The build tool is that critical, automated engine right in the middle that makes this whole beautiful chain of events possible. So let's just pause and recap the most important things to take away from all this. First, build tools automate that messy path from source code to a working application, and they do it reliably, every time. Second, we saw the evolution, from Ant's pure flexibility to Maven's powerful conventions, and finally to Gradle's focus on high performance. Third, remember the keyword, artifact. That's the key output, the deployable piece of software. And finally, and maybe most importantly, these tools are the absolute heart of any modern CI/CD pipeline. And really, this quote says it all. In professional software development, boring is actually an amazing thing. Boring means predictable. It means repeatable. It means things are just working exactly as they should every single time, without any drama. That's the rock-solid stability that these tools bring to the table. And that brings us to one final thought. We've seen these tools evolve from simple XML files to complex code-based systems to meet new challenges. So as we move into an even more complex future with things like microservices and containers and cloud-native apps, what new problems will the next generation of build tools need to solve? It's a fascinating question and one that will define the future of building software. Thanks for joining this explainer.